Hey everyone, today I'm going to go over a couple of Houdini things, and this is a bit new on my channel, and it's a program I've been kind of exploring and using in applications in the professional world and also in kind of my own design work. So I want to go over this amazing piece of software that I think can be used in a lot of different ways, and I'm kind of really excited to show you guys some more content, whether it's Grasshopper and Houdini. I think mainly I'm going to go towards Houdini just for now, but definitely if I see something interesting for Grasshopper, I will definitely show that as well. But this is like kind of like a new tool syndrome where I'm really interested in like learning the capabilities of this tool and kind of the pitfalls of it as well, to know when to use Grasshopper and when to use Houdini, because they are very similar in how they behave. They're also very similar in just like how you'd model as well. Like they just feel similar after using them for. I obviously have more experience in Grasshopper, but having a little bit more experience in Houdini, I can see a lot of similarities in how they work together. And if you're interested in some sort of bridge between Grasshopper and Houdini tutorial to understand like the differences and how you can apply them in your design work, then that's something I can definitely do as well. So today I'm going to go over something called forcing the Boolean operation. And in Houdini in general, like the Boolean operation works decently. So if you just have these and then there's no polygons and you just kind of subtract from, subtract with, it does pretty well. Sometimes though, if your geometry isn't like the absolute best or you have some crazy thing, it will freak out and produce bad edges, or it just won't Boolean altogether and it'll just not work. So this is kind of a way of forcing it to work, quote unquote. So to do that, we have to understand how a Boolean operation even works. So basically, we're just taking this object and we're subtracting it from the kind of scatter nodes, so like multiple pig heads in this case, onto the object. And what I want to do is subtract from this object with the multiple pig heads. And you're wondering, okay, how does that exactly work? So Booleans in general just work with a splitting. So we would just split the geometry. In this case, we would split the geometry based on this from this. Then from there, we would just unionize everything in the subtracted geometry. So in this case, we're just unionizing all this together. So that'll be a simple Boolean union. I just noticed this doesn't have a space. Sorry, that was bothering me. And then find the intersection of the subtract from geometry with the unionized subtract with geometry. And then finally, we just kind of merge them together, doing some fuse, polyfill, and clean node. So let's get started. So we'll just start with a simple Boolean union. So let's actually just go to number 2 real quick. This one's easy enough. We just set this to union and then keep that as is, and then no polygons here. Now, if no objects are intersecting, it'll just triangulate everything. In this case, there are, let's just put this to 20. I just want something to intersect so we can see. Yeah, there we go. So we have some intersection there. So let's go back to step 1, splitting up the geometry. So if we do that, we just do a Boolean operation. And then we just take this and then split from this geometry. And right now it's doing a Boolean difference perfectly, but it won't always do this. So sometimes you need to force the Boolean like I was talking about before. So in this case, we're going to treat set A as a surface. So we're just splitting it. And we're actually going to triangulate everything by doing no polygons. Perfect. So now we're just left with this pig head with the surfaces split. So we did number 1 and number 2. Now we need to do number 3, which is intersection of the geometry with the unionized version. So let's do that. So we do another Boolean. And then we'll just do an intersection. If we look at this. Actually, let's just merge these together so it's a little easier to understand what we're trying to do. So now we just need to subtract or intersect in the intersection of the main geometry with this geometry. So you can kind of theoretically put this in any order. If we do surface, no, wrong one. We do surface here. Oh, no, it has to be subtract with and then subtract from. And then we treat this as the surface. And then we do intersection. There we go. Theoretically, you can kind of do this, like I was saying, in any order. But you need to swap this constantly. So it doesn't matter as long as you just remember which set is treated as your surface. So now we have these two. So for example, if we actually chop these and then merge these two together, we're left with this. And actually you can see it's merging them perfectly together like that. Let's actually change this also to no polygons. And now we're left with something like this. So you can see we actually have the two pieces. We intersection of the geometry. When we merge them together, we have this. But you can see the blue outline is showing that they're not fused together. So that's a problem. But we have the two pieces we need. Another thing we need to fix is that the normals are inverted. So the normals in here are inverted versus the outside of the geometry, or the subtract from geometry. So what we can do is actually, before we fuse, we can do a reverse. And we reverse this geometry. So it looks something like this. So now we know that the normals are facing the correct way. And then now we have it back into the right position. So what you can do here is you can do a fuse swap as well. And then just kind of make sure also that these are, everything is set to no polygons. It's something I always forget. And it has this little weird overlap here. It's probably because this union, you need to plug this into here. Yeah, there we go. So if you have that weird overlap, I just didn't have the actual unionized geometry plugged into here. So you can fuse swap them, and then you're left with something pretty decent. Now this doesn't always work out perfectly. And also, like, fusing in general, especially when you have smaller triangles that you may want to keep, which is kind of rare, but you may want to keep. What I like to do is I don't like to fuse everything together. It doesn't make much sense because you're just wasting time fusing stuff that doesn't really matter. So what I like to do is I can do either a group. You can also use the Boolean operations to get these seams out of here as well. I don't like to do that per se, because some of them they're differently named. You can name them in here like set A and set B, but in this case, I'm just going to use the group node because we know that in these cases, in this case, all of them are naked edges, and we can actually just group those naked edges. So what we can do is do edges, turn that off, include edges, and then unshared edges. And we can also make sure we name this as like set A. And then here we can do set B. So I just copy and pasted that and then put set B. And now we're left with these two edge groups. And one thing we can do in the fuse swap that I really like, is you can do something where you can target the groups. You can do this in a lot of nodes, but you can target the groups on which groups you want to fuse together only. Now you can see though, if we have a drop down, we don't have our groups. And the reason why is because we have them as edge groups right now. We want these actually as points. So yeah, you can use these edge groups, but then you'd have to do a group promote as well. In this case, you don't need to do a group promote. You can also just take a points approach and just grab the points of those. So just make sure they're points. Now when you go back to fuse swap, you can go to set A and then set B. Now it leaves you kind of with a little bit of a weird topology or kind of weird edges here, but you can also just take a polyfill here and then just go to single polygon and then fuse these together. Actually, the fuse did a little better, just isolated. But the reason why this did so well before, so if we turn these off here. Oh, oops, I did the wrong ones. There we go. No target group. and we fuse that. One thing we can also do is when we set A and set B together, we can also change this to closest target point. So we have the least target here, which is going to do kind of for cloud reduction, but you can also do for disjointed pieces, and it will work a lot better. You can see all the vertices are actually in the right spot here, and you can just kind of fuse these together, which is perfect. That's what we want. Kind of like that. And then what I like to do to ensure things is I just add a polyfill. Now this polyfill isn't going to actually do anything. In this case, this is no unshared edges, as you can see. But this is just like kind of quote unquote insurance, just in case something weird happens. And yeah, that's pretty much it. So this is a forcing a, in this case, if we say here, like a quote unquote forcing Boolean operations. In this case, it's a difference that we did. Let's just not save that for now. One thing too also is you can group these together. So if we group these parts together, so the subtract from, we want to keep this, so we'll just say, we can say subtract from, or we can also still call it, and we'll just say subtract from in this case, and then keep that as is. Just group everything together, and then group this together, and then say subtract, and then underscore with, and then you got this. Perfect. We got this perfect geometry here that we have grouped together as primitives. And what we can do now is actually color these to know what's going on. Just purple. Doesn't matter the colors really. Just make sure they're different. There we go. Purple, red. Now we can specify which groups we want to have. So from, and then with. You technically don't need to put a group in here, but I like to specify. This should be with. And there we go. You could do points. You can see if you want it to be the color to be sharper, you can just change these to primitives. Ooh, oops. Prim. There we go. But you can leave it as points if you want. It doesn't really matter. It's just mainly to show like what you're subtracting. In this case, I actually prefer this to be from, or if I could spell from, and I want this to be with, something like that, and then we have this. Perfect. Nice. So this is how you force a Boolean operation in some way, and a lot of the concepts you can do by understanding how these things actually work to kind of manipulate in your favor. So you can actually, I've already created just some tests with this. I've already created an HDA that does something similar as well. In this case, I was playing around with softening the edge of the Boolean operation. So you can actually see how this works. In this case, you need to actually remesh it a bit as well. In this case, I just kind of threw on a fast remesh with no smoothing or barely any smoothing iterations, like 0 literally. And then smoothing that out. And then only taking specific parts of the mesh to smooth out. So in this case, I'm smoothing out this part and then smoothing out just those edge areas using kind of a group expand. And then when you merge them together, they look something like this, which looks pretty cool. And I actually think in an animation of a scatter or some noise would look pretty cool on this thing to show the Boolean operation really showing. And then maybe something I'll do in the future just to show off this node. But this would be available. I'm going to make this available on Gumroad, I think is what's called. So you guys can play around with it. It's definitely not completely done. There's a lot of bugs with this specifically. And I also have only tested this out with like a couple things. So the test pool on this is pretty low. But for now, I think this concludes my tutorial on forcing the Boolean together. So thank you guys for watching. I hope you guys really enjoyed this. This is kind of new for me, and I can't wait to do more content revolving around Houdini and Grasshopper and kind of how they work together. So yeah, guys, see ya.